Welcome to our comprehensive guide on data mining. In today's digital world, companies generate massive amounts of data every single day. But data alone is not useful. What matters is discovering valuable patterns and insights hidden within that data. Data mining is the process of analyzing large datasets to uncover meaningful patterns, relationships, and trends that can be used for decision-making. Think of it as searching for gold in a mountain of raw ore. You collect the ore, process it, and extract the precious gold inside. Similarly, data mining helps organizations transform raw data into actionable intelligence that drives business growth and innovation. Data mining uses four primary techniques to uncover patterns. First is classification, which assigns data into predefined categories based on existing patterns. For example, classifying emails as spam or legitimate. Second is association, which finds relationships and connections between different items. For instance, discovering that customers who buy bread often buy milk too. Third is clustering, which automatically groups similar data points together without predefined categories, like organizing customers into groups based on their shopping behavior. Fourth is prediction, which forecasts future values based on historical patterns. For example, predicting next quarter's sales based on past data. Each technique serves different purposes and is chosen based on your specific business problem. Data mining uses two learning approaches. Supervised learning works with labeled data, meaning the answers are already known. You have training data where the correct outcomes are marked. The algorithm learns these patterns and applies them to new data. Classification and regression are supervised tasks. For example, predicting house prices using historical price data. Unsupervised learning works with unlabeled, raw data where answers are unknown. The algorithm must discover hidden patterns on its own. Clustering and association are unsupervised tasks. For example, discovering customer segments without predefined groups. Think of it like this. Supervised learning is like learning with a teacher providing answers. Unsupervised learning is like exploring a new place on your own and discovering interesting areas. Both approaches are valuable depending on your data and business objectives. Several tools make data mining accessible and practical. Python is a powerful programming language with rich libraries like Pandas, scikit-learn, and NumPy that support data mining tasks. R is a statistical computing language specifically designed for data analysis and visualization. RapidMiner provides a visual drag-and-drop interface, making data mining accessible without extensive coding. Orange is an open-source tool with a visual programming interface perfect for machine learning. KNIME is another open-source platform that combines data mining with visualization capabilities. And Weka is a machine learning software offering a comprehensive suite of data mining algorithms. Your choice depends on your technical expertise, budget, and specific requirements. Beginners often prefer visual tools like RapidMiner or Orange, while experienced professionals may use Python or R for more control and flexibility. Data mining transforms industries across the board. In healthcare, it's used for disease diagnosis and identifying high-risk patients before complications occur. In retail and e-commerce, it analyzes customer behavior and basket patterns to recommend products and optimize inventory. The finance sector uses data mining for fraud detection and credit analysis to prevent financial crimes. Telecom companies optimize networks and predict customer churn to retain subscribers. Manufacturing uses it for predictive maintenance, identifying equipment failures before they happen, and ensuring quality control. Energy companies forecast power demand and detect faults in their systems. These applications save companies millions of dollars, improve customer satisfaction, and enable faster decision-making. Essentially, any industry handling large datasets can benefit from data mining insights. Despite its power, data mining faces significant challenges. Data quality is a major issue. Noisy, incomplete, or inconsistent data leads to inaccurate results. Garbage in means garbage out. Privacy and security are critical concerns. Protecting sensitive customer information while mining data is essential for regulatory compliance and maintaining trust. Scalability is another challenge. Processing massive datasets in real time requires powerful infrastructure and efficient algorithms. Interpretability is equally important. Complex machine learning models often work like black boxes. Understanding why a model made a particular decision is crucial for gaining stakeholder trust. Additionally, finding skilled professionals, selecting appropriate algorithms, and managing computational costs can be challenging. Success in data mining requires addressing these limitations through careful planning, quality data preparation, and choosing appropriate techniques. Data mining is evolving rapidly with exciting technological advances. Artificial intelligence and deep learning are being integrated into data mining for more sophisticated pattern recognition. Real-time analytics enable instant insights from streaming data instead of batch processing. Cloud computing provides scalable infrastructure to handle ever-growing datasets without massive upfront investments. Internet of Things, or IoT devices, generate continuous streams of data from sensors worldwide, creating new mining opportunities. Predictive analytics is becoming more accurate, helping businesses anticipate future trends with better precision. Data privacy and ethical frameworks are increasingly important as regulations like GDPR reshape how we handle personal information. Automated machine learning, or AutoML, is making data mining accessible to non-experts by automating model selection and tuning. These trends indicate that data mining will become more powerful, accessible, and integrated into everyday business decisions. Data mining expertise opens numerous career paths. Data scientists design and implement mining algorithms to extract insights. Data analysts work with data to create reports and identify trends. Machine learning engineers build production systems using predictive models. Business intelligence analysts translate data into actionable business strategies. In-demand industries include IT and technology companies with the highest salaries and competition. Finance and banking offer lucrative roles in fraud prevention and risk analysis. E-commerce and retail companies hire extensively for customer analytics and personalization. Healthcare and pharmaceutical companies need data miners for drug discovery and disease diagnosis. The data mining field is booming. According to industry reports, demand for data professionals continues to grow faster than supply. Starting salaries for entry-level positions are competitive, and experienced professionals command premium compensation. The field offers career stability, remote work opportunities, and the satisfaction of solving real-world problems with data. Multiple resources exist to build data mining expertise. Online courses on platforms like Coursera, Udemy, and edX offer structured learning from basic to advanced levels. Many courses are free with optional paid certifications. Practice platforms are essential for hands-on experience. Kaggle hosts competitions and datasets for real-world practice. The UCI Machine Learning Repository provides free datasets for experimentation. GitHub allows you to study others' code and contribute to projects. LeetCode helps sharpen programming and algorithmic thinking. Recommended books include Data Mining Concepts and Techniques, Machine Learning Tools and Techniques, and Data Mining for Customer Relationship Management. Join online communities, attend webinars, and participate in local meetups to learn from peers. Consistent practice is crucial. Start with simple datasets, gradually increase complexity, and build a portfolio demonstrating your capabilities. The combination of structured learning, hands-on practice, and community engagement accelerates your journey to becoming a proficient data miner. Data mining is transforming industries by converting raw data into valuable intelligence. From healthcare saving lives through early diagnosis, to retailers understanding customers better, to financial institutions preventing fraud, data mining's impact is undeniable. The journey of discovering hidden patterns in data is both challenging and rewarding. You now understand the fundamentals of data mining, its techniques, tools, applications, and career prospects. The real learning begins when you apply these concepts to real datasets and solve actual business problems. Start small with simple datasets, gradually tackle more complex challenges, and continuously expand your skills. The future belongs to those who can extract meaning from data. Your data mining journey starts today. Embrace the challenge, stay curious, and master the art of discovering hidden patterns. The opportunities are limitless, and the impact you can make is significant. Begin your data mining adventure now.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.